Today I want us to take some time to review what it means to simplify radicals, how we do that, um, and maybe even a new strategy that you may have not used before. So one important thing to remember when we're simplifying radicals is make sure that you have either in your notes or somewhere this list of perfect squares to be able to look at. Those are going to be really important as we're simplifying because it's those perfect squares that'll give us a number that we can take out of the square root. And like I said, this should be some review. So we're just going to go through a couple of examples together to look at what this means to simplify. So for example, if we're starting here with the square root of 32, you'll remember that what we want to do is we want to find one of these perfect squares that I can divide 32 by. And I see that in 32, that number is going to be 16. So what I can do is I can rewrite this as it's actually 16 times 2. Okay, and 16 is 4 squared times 2. Anytime we see those squared numbers, those are what we can take out of that square root. So because this is a squared number, it's going to come outside in front, but we're just going to write it one time. So this is going to become 4 times the square root of 2. Now you may have learned to simplify radicals in this way where we're dividing by those perfect squares, but I want to give you an opportunity to see it maybe a different way. Maybe finding those factors is a little bit tricky for you. And so I want to show you another strategy that you might use. And you'll remember back from when you learned factors, you may have made what was called a factor tree. And that's a strategy that I want to show you here today. So what we're going to do is we're going to take this 600. I'm doing this not under the square root because I'm not worried about the square root of it right now. I just want to find the factors of that 600. So I think about 600 and I think, well, what times what is 600? And the first thing that comes to my mind is 6 times 100. You may have written this number a different way, and that will be okay as long as you're showing kind of how you're breaking it down. So then I do the same thing to both of these. So 6, I think, well, that's a 2 and a 3. And this 100 is 10 times 10. Now what I like to do is anytime I get to a number that I can't kind of break apart anymore, I just like to circle it so that I remember it's there, but I might be simplifying other numbers more. So then I can break up this 10 and say, well, this is 2 times 5. Well, 5 there. 2 times 5 and 2 times 5. Those are both prime numbers. I can't break them apart anymore. So we have these 2's and these 5's. Okay, so now I've gotten to the end of my factor tree. And what you can see here, oh, one of them is over a plug back there, isn't it? There we go, that helps a little bit. What we can see is that we have 2 times 2 times 2, right? I have 3 of those, times 5, times 5, times 3. So these are all my factors. Those are really what is inside that square root. Now, the really important part about simplifying radicals, and we did the same step right over here, is I can only take things out of that square root if there's 2 of them. So any place I see 2 of the same number, I'm just going to circle it. Those are what can come out. So I can write a 2 times a 5, right? They just come out as one of those numbers. And inside there's still a 2 and a 3 left over. So what this means, you can see it a little bit there, right? What this means is the square root of 600 is really this, that 2 times 5 times the square root of 2 times 3, or we multiply those things back together, 10 times the square root of 6. Okay, another strategy that you may use, but by no means is the one that you have to use. Okay, let's go ahead and look at a few more examples. Now remember, you have learned these at some point in the past, and so if you remember a different strategy that works for you, by all means use that, okay? But what we want to look at is we want to look at this 20, and we're going to break it into our factor square. So as we look at this 20, I want to break it apart. Remember, you can break it apart any way you want. We should end up with the same factors at the end. So for example, if I do a 2 and a 10, well, I stop at a 2, right? I can't break that up anymore. And then I take this 10 and I see a 2 and a 5. And those are both going to be the end. So I don't have anything else to break up. So this square root of 20 really is 2 times 2 times 5. Okay, now remember, what I want to do is I want to look and find any doubles that are there. So there's 2 2's, so I'm going to circle it just so I remember. And one of those will come to the outside, and we only have that 5 left inside. Okay, let's do it again. 44. So I'm going to write my 44. And I can break this into a 4 and an 11. 11 is a prime number, so I'll stop there. And this 4 can be broken into 2 and 2. And those are both the ends. So I'm really dealing with the square root of 2 times 11. Because there's 2 of those 2's, I'm going to circle them so that I remember. And one of them will come to the outside, and that 11 is still in your square root. Okay, we got to this last one. We're at 50. I'm going to break that up as 25 and 2. You may have done 5 and 10. That's okay also. I'm going to do a 25 and a 2, and then this 25 can become 5 times 5. Okay, so really in my square root, I'm really dealing with 5 times 5 times 2, because there's 2 of these 5's, I circle them, and 1 comes to the outside, and that 2 is still on the inside. So a little review. Let's take a look at a few more. Okay, these are the last 2 that we're going to look at here as review, but you'll notice that now we're dealing with radicals that also have a number outside of the radical that we have to take into account. So again, we're going to look at just breaking down that 200. Don't worry for now about that 3. We'll look at it here shortly. I'm going to break this into 2 and 100. 2 is the end, right? And then I have maybe I'll break this into a 2 and a 50. And I'll break this into a 25 and a 2. And then finally that 25 becomes 5 and 5. Okay, the main thing that is helping us to do is to find all those factors. Now, if you can do this without mistakes, without drawing the tree, that's absolutely okay. But this is just one strategy that might help you to take into account all of the factors in this number. And so now what we're going to do is we're going to rewrite this. I'm going to move it right over here. We want to remember that 3 out in the front. And inside, really, we have 1, 2, 3 2's. 2 times 2 times 2. And 2 of these 5's. So remember, I'm going to circle any 2 that I see. You'll see there's another one, but it doesn't come with a partner, so we're not going to circle it. And we're going to take those 2 5's. So I'm going to move those to the outside. So we're going to have 3 times 2 times 5. I still have 1, 2 left on the inside there. Okay, now notice we're multiplying all these numbers together. So 3 times 2 is 6, times 5 is 30, and that's square root of 2. So this would be your number simplified of 3 times the square, there we go, 3 times the square root of 2. Okay, so you're leaving that number on the outside, just multiply it by what you find of the simplified part inside. Let's look at one last example. Again, I'm going to take a look at this 98. Now, if you're not sure how to factor it, remember this is an even number, so I can always divide an even number by 2. And then this is going to be 49. Okay, 2 is the end. 49 can become 7 times 7. Those are both prime numbers. I can't simplify them anymore. So now I'm going to go ahead and put it back into my square root. Remember, I do not forget that 5, it still has to stay on the outside. And we have 2 times 7 times 7. And as I look, I have 2 7s here, which means it's going to come right out of that square root. 2 stays in there, it doesn't have a partner. So 5 times 7 is 35 times that square root of 2. This is your simplified version of that value that we started with.